Hi, welcome to my third lesson on Urweb. So today we're going to be implementing the final state of this web application. And so after this lesson, we're essentially just going to be making modifications on this web application to show off different points of Urweb's model. And I think that this application will be simple enough for anybody to understand, but complex enough so that it allows for a lot of different ways to examine how the different parts of Urweb interacts with itself. So interestingly enough, we aren't going to be saving much code from this at all, or any code at all from the previous example. Instead of having a function called new counter, we're actually going to have a counter type and then simply a ShowCounter function. And so here's the type. And we're going to show that XML. So something you may have noticed is that this doesn't return a transaction of XML anymore. It actually just returns a regular XML, and that's definitely a benefit in terms of simplicity that we'll get to pretty soon. But just like any Urweb application, this requires a main function, and like normal, it will actually return an XML document. So it seems to work. And so just like the previous example, we're actually going to have a source list, but it's going to be a list of counter. But not really. It's actually going to be a list of source counter. And I'll get to that in a second. The main reason is that ShowCounter is going to contain the delete function, the delete functionality, and so it's going to need a reference to itself, essentially. So we can't just pass in the counter at some state. We need to pass in the source of the counter so that it can modify the counter. And you'll see why in just a sec. So here we are. Let's display this counter. So it's going to take a source counter. And just like before, we're going to have a dyn tag with a signal, and that signal is basically going to take the signal of that source, and then it's going to return some XML. And that XML is just the state of the count. Very simple. And so that's complaining again that I forgot a parenthesis, or that I forgot a slash. And that's complaining that I forgot a semicolon. And that compiles. All right. Nothing interesting so far. So now let's make a counter, and we'll give it a count of 0, and then let's append that counter to that list. And like we expect, well, we're not displaying the counters, so let's this list source may have the value of the counter, but we can't see that yet. So let's add a body. And also, just like before, we'll be using a dyn tag, and we'll be grabbing the state of that list, and we'll be returning the list, but we'll be mapping over with mapx just like before over that list, and we'll be just using ShowCounter, which is defined right here, over that list, and that should be it. Okay, so hopefully get a 0. Good, just like expected. Whoops, apologies. So next what we want to do is, obviously this is pretty boring. We can't change the state of this counter. So we'll add a button, just like before. And that button will have a value called increment. And on click, what it's going to do is take the state of the application, which we're going to ignore like usual, and we're going to get the state of the source counter. And then what we're going to do is we're going to set the source counter with the count is equal to the previous count plus 1. And it's complaining I forgot this again. So there we go. And here we go. Got an incrementer. Yay! Excellent. And let's add a decrementer. Why not? Minus. So as you can see, there's a little bit of code duplication that's here, and we're going to get to that to removing this code duplication in just a second. The thing is that this isn't showing off what I think is one of the most important parts of Web, and I'd like to show that to you right now. So let's say that we added some foo with a bool, right, and some bar with another bool. As expected, this won't compile, and the reason is because we need to go around and add some values everywhere. But then we get into the situation where, okay, now we're having a foo equals c dot foo and bar equals c dot bar, and it's just not very nice. That will compile. That works, just like before. But as you can see, that's a bit tedious. And Web has a really excellent syntax for getting around that problem. So what we do instead is that we'll use some special syntax that Web has for dealing with record updates. So we're going to take that counter and we're going to remove the count field. And then we're just going to add that count field back in like so. And so what this will do is that this means that this function is polymorphic over the rows that are additional to just the count field. And so we'll give the same treatment here. We'll just remove the count field and then add it back in -1. And that works. So now we're no longer having to explicitly state that there's a foo and a bar in here and rebinding it. All this lets us do is just to do this update and then add that update back into the record that has that count field removed. So it's a very general way of working with records in a way that doesn't require us to update the contract. It would just say that this requires some field that has a count, and if it does, then it'll compile, and we'll update it based on these buttons. Makes it very simple. So let's get rid of foo and bar because those are unnecessary. And so since the impetus for this tutorial is now to keep adding on to lesson 2. So let's re-implement lesson 2. Let's let's add a new button that the value is add. And so what that will do is on click will add a new new counter. So when it's clicked, we ignore the state of the world just like before. And so we'll get the list source right here. And then we'll create a new source counter, which is just the source of the counter with an initial value. And then we'll just set the list source with the new source counter appended to the front of the list. And that's it. That is it. Just like before, now have a new thing. Let's add some breaks just to make it a little bit more visible. So just like before, we've got now this stack of counters, although we don't have the delete function. And as you can see, it's adding it from the top again. So just like before, let's do a little list.reverse on the list. And now it'll add it to the bottom. I'll keep the top the same. Okay. And now obviously the impetus of this lesson is to add a delete button. So we want to have a button here that will delete this specific counter. And how we're going to implement that is that we're just going to hide it. That's the simplest way to do it right now. So we're just going to have this show field that will add a new button that will modify that show field. And this is why this is very important, this update syntax, is because now that we've added this show field, we don't have to change this code at all. If we were to explicitly name all the records and update them in place, we would require, if this was a large application, going through a whole bunch of different places and updating those record updates. Well, here it's completely polymorphic over the rows that it doesn't care about. So let's add that button where the value of delete, and then on click, we'll execute getting that source counter, and then it'll set the source counter with the new value of show to be false. One sec, it will be false. There we go. So all this will do is just set the source counter, and it'll set show to false. And this won't do anything if we save this. All we're going to do is let's remove this line, because now we're not interested in having a default counter. And then we'll show equals true here. And that should compile. So now we've got the same thing, but with a now a delete button for each of these. And so the delete button doesn't work. It does set the internal counter to false, but obviously, as you can see, it does not remove it from the screen. So how we remove it from the screen is that we will filter based on that state. And how we do that is that we'll find this new list, maybe let's call it NL for new list, and then we'll do a filter on it. But the thing is that we're having to filter based on sources. So if we just had a list of counters, we could use list.filterm. But because we're filtering a list of source counters, and because source is a monad, don't worry about that scary word. We're having to do a filter based on the filter M on that because it's inside of a monad. And that'll become very clear. It's essentially the same syntax. So here, here we go. We define some x, give some x inside of this list. What we do is that we get the state of that x, and we'll just return if x.show is not equal to false. And this is going to complain. It's going to say that it is expecting me. We should not be getting x. We should be getting the signal. There you go. And so this is still not going to work because obviously we click these deletes. So what we need to do is now set the value to that new list right here. So when we compile that, it should work now. There you go. Deletes it. And so, like expected, we've got now we have a heap of counters instead of a stack of counters. The one thing though is that if we actually inspect the DOM inside of here, you may notice that when you add additional elements to this DOM, what will happen is that because we're merely filtering out the based on the show functionality, it will actually keep around these older DOM elements on the in the list. And so you might think that, okay, we can just set the list to the new list here. The thing is that Ur-Web disallows that, and it disallows that for a good reason, because signals are basically a read-only operation. They're meant to just display. They're just a display, and so you're not allowed to do any kind of mutation inside of a dyn tag, inside of a signal of a dyn tag. So what we'll do is instead, we'll just copy this function, place it right here, and so this is kind of interesting, and we'll just get instead of the signal. So anytime that the add button is clicked now, it will actually filter. Let's make it the new list now, not the old list. It'll filter the DOM elements out that don't have this, and it will then clean up the DOM essentially, so that you're no longer having these elements lying around on the DOM. They're actually being so when you delete it, it just shows, it just hides it, but then when you add it, it then filters through all the DOM elements and then actually removes them from the DOM. Because here we're just showing based on this signal, while here we're actually filtering and then setting this source to this new filtered list. So this actually removes the DOM elements, while this only hides the DOM elements. And this will actually be the impetus for lesson 5, is how do we abstract this filter function across these two different monads, because here we're getting the signal and here we're actually getting the value. So we're interested in abstracting this so that we can make this filter function work over any monad, not just these specific monads. So tune in for that. Next lesson, we're going to be abstracting these record updates. So see you then.